Hi Year 11, this is our second video for the topic of statistics for the International Baccalaureate course Analysis and Approaches. In this lesson, we're going to look at measures of central tendency, measures of spread, displaying data, outliers, cumulative frequency, and finish off with variance and standard deviation. So after we've collected the data, organized it and graphed it, we need to analyze the data in order to draw conclusions. And there are two broad statistics that we're interested in. What is the center of the data and what is the spread of the data? So let's begin with measures of central tendency. We're trying to find the center of the data, and there's three statistics that we use: mean, mode, and median. We're going to talk about two different means. There's an arithmetic mean and a geometric mean. The arithmetic mean is the one that you're used to. We find it by adding all the data values together and dividing by how many there are. This is what this formula means. Here's the symbol for the mean, x with a bar over the top, is equal to the sum of all of the data values divided by how many there are. Here's an example. Finding the mean of these numbers, we just add them up. There are 7 altogether, so we divide by 7. And our mean is 5. Now the geometric mean is found by multiplying all the data points together and then taking the nth root. So it's subtly different. Same example, find the geometric mean of these numbers. We're going to multiply all those numbers together, and then there are 7 of them, so we will take the 7th root. So it's equal to 4.14. Let's move on to median. The median is the middle term. There is no widely accepted symbol. Now, if there's an odd number of data, then there will be one middle. But if there's an even number of data, there will be two middles, in which case we just find the average of those two numbers. Note, the data has to be put in order first. That's really important. Here's an example. Find the median for this data set, 1, 3, 2, 4, 6, 2, 3. Let's put it in order. And we cross off from either side like this until we reach the middle. There's only one middle here, so our median is 3. We talked a bit about the mode in the last video. The mode is the most common score, and it's typically used for categorical data, but not exclusively. If there are two modes, the data is said to be bimodal. If there are more than two modes, we say the mode doesn't exist, and there is a reason for this. In real life, this is not uncommon, getting two modes. If you think about the heights of humans, there would be a mode for females and a mode for males. But more than two modes, like trimodal, there's not many, if any, real-life applications for that. So this is our rule. More than two modes, the mode doesn't exist. Here's an example. State the mode for this set of data. It is 6. Let's have a look at how to use the calculator. I'm using the Casio 9860 GII. We need to go into Stats, which is number 2, and we're going to enter our data into List 1, like this. Then we're going to go to Calc, which is F2, and then we want one variable statistics, which is F1. Now you will see all the statistics that you need there. Here is the mean. For the median, you scroll down and you will see median here. And scroll down again and you're going to find mode, which is here. Now, if there's more than one mode, they will all be listed, even if there's more than two. So you need to be mindful that if you see more than two modes, then you say that there aren't any modes. From a frequency distribution table, we'll use this formula for the mean. So this means the sum of the fx column divided by the sum of the f column. So suppose we have this frequency distribution table. Here's our scores, here's our frequencies, and the fx column just comes from multiplying f by x. That's going to give us these numbers here. It kind of does a total of each of the data points. So 1, 0 is 0, 5, 1 is 5, 6, 2 is 12, and it totals them as we go. Now we want the sum of this column, which tells us how many values there are, and the sum of this one, which gives us the total sum of all the values. So there's 29 scores, and the total is 81, and we just do this division. So our mean is 2.8. Quick check. It should lie somewhere in between these values. You wouldn't want an answer of 12, for instance. 2.8, that looks reasonable. On the calculator, this time we're going to use two columns. So we're going to enter the X values, or our values, into list 1 and the frequency into list 2, like this. Now we have to adjust the calculator. This is what we do. We're going to go into Calc, and then you're going to find Set, F6 Set. And it says that our X values are sitting in list 1, and our frequency is 1 each time. We don't want that. We want the frequency to be in list 2, where we put them. So we just hit list, and then 2, and that's what we get. Now you exit out of there, and we just do what we were doing before. Hit F1 for one variable statistics, and then read off the mean or the median or the mode as required. Now I should say that you need to become quite proficient changing between these two, because sometimes you want a frequency of 1 when you've got just individual values, but if you've got a frequency distribution table, then you need to change it to this. With group data, we create our frequency distribution table like we did in the last video. We add an extra column for the mid-interval value. So this mid-interval value is just found by averaging the cutoff points for each class. So 50 plus 60 divided by 2 gives us 55. And so this becomes like our X. And we can still do our FX column, or we can still put this in to the calculator if we need to. There it is there. Now we can use our graphics display calculator to draw a histogram. Let's have a look at how we do that. I've already entered the data, the X values into list 1 and the frequencies into list 2. We want to graph it, so I'm going to go F1. Now there are 3 positions that we can store graphs in, and we need to set it up. So I'm going to go to set, which is F6. All right, currently it's a scatter graph. We don't want that, so let's come down, and you have to scroll through until you find histogram. There it is. F1. Let's check this. X list in list 1. We need to change our frequency. We don't want a frequency of 1. We want it to be list 2. Okay, exit out, and now we need to graph it. So F1. It says starting point. We do want to start at 55, and it says a width of 4.45. Let's see what that does. Okay, so it gives us a column graph. Now it probably is discrete data, discrete grouped data, so that would be perfectly fine. But if we wanted continuous data, we would just move those closer together. So hit F1, and we would want the width to be 10. And there you have it. Now let's return to the shape of the distribution. With symmetrical data, the mean, mode, and median are equal, like here. But when the data is skewed, they're not equal. So remember, if we've got a negative skew, like this, our mode is where the hump is. And in this case, we're going to have the median just to the left, and then the mean just to the left of that. And I might have mentioned in the last video that the mean take away the median gives us the sign of the skew. So in this case, I'm doing a smaller number, take away a bigger number, which is what gives us the negative. So this is a negative skew. Here's our positive skew. There's the mode, and then there's the median and the mean. This time I'm doing a bigger number, take away a smaller number, and so that's going to give me a positive number, so hence this is a positive skew. Now it's important that we talk about the difference between mean, mode, and median. Which one do we use? The mode is the preference for categorical data, but we can use it for numerical data as well. Mean or the median is only used for numerical data. Now the difference between the mean and the median is preferable if there are outliers, because the mean will be affected. Okay, let's move on to measures of spread. To accurately describe a data set, we need to measure its center, but also its spread. And most commonly we use the range to determine how spread out the data is. And the range is simply the maximum value take away the minimum value. So if we want to find the range for this data set, we're going to take the maximum, which is 99, and subtract the minimum, which is 1. So the range is 98. Another way to work out the spread is to use quartiles, and a set of data can be divided into 4 quarters by using the lower quartile, the median, and the upper quartile. Let's find the upper and lower quartiles for this data set. Now the first thing we have to do, just like when we're finding the median, is put the data in order. So there it is, 0, 1, 2, 2, 3, 5, 7, 9. We're going to start by finding the median, so just chopping off from either side, we find that the median is in between 2 and 3. And so we average those two and we get 2.5 or 2.5. Now we're going to find the median of the lower half of the data and then the median of the upper half. So the median of the lower half will be the lower quartile and the median of the upper half will be the upper quartile. You can probably see here that the lower quartile is going to be 1.5 and the upper quartile is going to be 6. Now the median is never included when we're working out the quartiles. So suppose we've got this data set 2, 2, 3, 4, 5, 5 and 8. When we work out the median, it's going to be 4 and we're going to actually cross that out. Now working out the lower quartile is going to be 2 and the upper quartile is going to be 5. The interquartile range is found by subtracting the lower quartile from the upper quartile. Let's find the range and interquartile range for this data set 2, 3, 7, 1, 4, 99. We worked out the range before. It's 99 take away 1, which is 98. Now let's put the data in order. The median is going to be 3.5. The lower quartile is 2 and the upper quartile is 7. And so our interquartile range is 7 take 2, which is 5. Now do you notice something? Look at the difference in these numbers. The range, just like the mean, is really influenced by outliers, and that 99 is definitely an outlier. So one way to avoid that is to use the interquartile range. Now we can use our graphics calculator to find the upper and lower quartiles. Just like before, we're going to enter the data into list 1, and this time we want a frequency of 1. So hopefully you remember how to change that. You've got to go into set, and you've got to set the frequency to 1, not to list 2. And then we would go into calc and into Univariate, and if you scroll down you will find Q1, median and Q3. There they are. It won't tell you the interquartile range. You'll have to actually work that out yourself. So you've got to go 6 take away 1.5, but that's pretty easy. Which brings us to the 5-number summary, which is a set of 5 statistics that summarize a data set. And the 5 numbers are the minimum, the lower quartile, the median, the upper quartile, and the maximum. And we can get all of those from our calculator. So let's write a 5-number summary for this data set. We've got the numbers 1, 4, 4, 7, 8, 9, 11. We'll start with the minimum. That's nice and easy. The maximum is 11. Now let's do the median, which is 7, and we're going to cross it out. The lower quartile is 4, and the upper quartile is 9. There's our 5-number summary, which leads us nicely into a box plot, because a box plot uses the 5-number summary to display the data. So here is our data. The minimum was 1, lower quartile 4, median 7, upper quartile 9, and the maximum was 11. This is how we draw our box plot. You will see sometimes they will have straight lines here instead of the dots. It's perfectly fine either way. This is the minimum. Then we've got lower quartile, median, upper quartile, maximum, and we draw a box around that middle 50%. And what's really important is to realize that there are 25% of the scores in each one of these quartiles. So you can see that this particular part here is quite bunched together. So the data set is slightly negatively skewed because there's more data in here and it's more spread out here. It takes a little bit of time to be able to understand that, so you might need to draw some rough sketches of data sets from box plots just to be able to pick whether it's symmetrical or positively or negatively skewed. We can also use our graphics display calculator to draw a box plot. Now, just like before, after you've entered the data, you hit F1 for graph, and then you need to store a box plot in one of these positions. So if you've already used graph 1 for your histogram, then choose graph 2. We hit F6 for set, and we find box for our box plot. Our X list is in list 1 and the frequency is going to be 1. You can have your outliers on or off as you see fit. Now we'll talk about that later. Then you hit XY and then you go into whichever graph it was that you chose, and this is what we will get. It's a really common question to be asked to compare box plots. So you'll be given some scenario, some statistics that have been collected, and you might be asked to determine the differences between the groups from the box plots. So what can we see here? We know this is the time taken to complete a shape recognition test. We've got females and we've got males. Right, first thing we can tell is that the male data is more spread out. Okay, it's less consistent, the females are more consistent. The males take longer on average than the females to recognize the shapes. The male data is basically symmetrical. The female data has a slight negative skew. Now you have to turn your head around so that these numbers here go upwards from left to right. So I'm turning my head towards the left. And I can see that it's really bunched up in here, and that would be a negative skew. And the female data has an outlier, which is here. So one person who was well away from the rest of the group. Now we can use our graphics display calculator to draw parallel box plots. And all we do is enter the second set of data into list 2. Now you're going to need to set up 2 of the graphs to draw box plots, say graph 1 and graph 2. Just exactly the same as you did before. One has to draw list 1 and the other one has to draw list 2. Then you hit F4 for select and you turn on the graphs that you want to draw. And this is what you'll end up with. So it's a good idea to have a practice of a few of these, drawing histograms and the box plots. Now we talked before about outliers, and a general rule for deciding if a data point is an outlier is to use these formulas to create the boundaries. The upper boundary is quartile 3 plus 1.5 times the interquartile range, and the lower boundary is the lower quartile take away 1.5 times the interquartile range. And that's just going to give us some cutoffs. So you saw before in the parallel box plots how the female data had an outlier. They would have used these rules to figure out that that was an outlier. Let's look at an example. Determine whether 0 is an outlier in this data set. 0, 13, 15, 15, 16, 22, 24, 25. The data is in order, so let's start by finding the median. It's in here. The lower quartile will be 14. The upper quartile will be 23. And the interquartile range is 23 take 14, which is 9. All right, we want to find out 1.5 times the interquartile range, which is 13.5. Now, if 0 is going to be an outlier, we're going to need to do the lower quartile take away this amount. So 14 take away 13.5 is 0.5. So that's the lower boundary. Is 0 below that? Yes, it is. So 0 is an outlier. And this is how we would draw it. Here's our outlier here. Our minimum is now 13. There's our lower quartile, our median, our upper quartile, and our maximum. All right, cumulative frequency. We use cumulative frequency to find the proportion of scores that lie above or below a particular value. Here's an example. For the data, complete the cumulative frequency column. Now this is a running total. We give it the heading CF. We're going to take the first one, which is 10, and shift it over. Then we're going to add the 11 on. And it gives us 21. And we're adding the 12 on, gives us 33. You can see how it's a running total. Add the 5 on, gives us 38. Add the 6 is 44. And add the 2 gives us 46. So we're accumulating the frequency step by step. And that number down the bottom is the total number of scores. So the same as if we had just added that up in one go. There are 46 scores altogether. If we want to draw a cumulative frequency graph, then we use the mid-interval values. So they are 5, 15, 25, 35, 45, and 55. We plot the cumulative frequency at those points and we draw a curved line between the points. And we can use our cumulative frequency graph to find the median and the quartiles. We're going to use the total frequency. So to find the median position, we will just do halfway. 50% of 46 is 23. The lower quartile will be at the 25th percentile. So 25% of 46 is 11.5. The upper quartile will be at the 75th percentile. 75% of 46 is 34.5. And now we just read them off the graph. They are all positions. They're not the answer. So let's have a look. Our median, so 23, we're going across to the graph and down. It's about 17. Our lower quartile, so 11.5, and reading off the graph is about 6 or 7. And our upper quartile, we want 34.5, so that's about here. And reading off the graph, we get approximately 27. You can see how it's not as accurate as using the real data. Which leads us nicely to percentiles. A percentile is a score under which a certain percentage of the data lies. We've already talked about the lower quartile, it's the 25th percentile, the median is the 50th percentile, and the upper quartile is the 75th percentile. Of course, we can have any percentage. Here's an example. Estimate the percentage of data that's less than 27 centimetres. So we're going to read off the graph the opposite way. We'll find 27 and read it off, and we're going to get 6 as our cumulative frequency. Now that's not 6% because it's not out of 100. It's going to be 6 out of 32. 32 is the total frequency, and then we times that by 100. So 19% of the data is less than 27 centimetres. Okay, last bit for this video. We're going to talk about variance and then standard deviation. So a more sophisticated measure of spread is the variance. And this measures how far the average score deviates from the mean. What on earth does that mean? So here, let's see if we can figure this out. Here's our individual scores. We're subtracting the mean, so finding the distance from the mean. We're squaring that so that we get rid of the pluses and minuses, and then we're adding them up and dividing by how many there are. That's the variance. The square root of variance is called the standard deviation. It's almost the same formula, it's just got a square root there, and instead of having sigma squared, we've just got sigma by itself. So that's the symbol for standard deviation. Now, standard deviation is particularly useful when the data is symmetrical. However, it can be affected by outliers due to its dependence on the mean. So let's just have a look at this example. A class of 12 students measured their weight to the nearest kilogram, and we've plotted them here. Now we've worked out the mean, that's this line here. What the standard deviation is the average deviation each of these scores is from the mean. The way we work it out is we find the difference between the score and the mean, square it so that we get rid of the plus or the minus, add them all up, divide by how many there are, and then finally take the square root. So one way to work this out is actually to do it by hand. Now I've actually used a spreadsheet here to do it just because the calculations are a little bit long. It's my data set, the mean, and here I've got xi take away the mean. So I've taken 51, take away 77.16667. I've copied that formula down. And then I've squared this column to get rid of the pluses and minuses. I've added them all up and then divided by how many there are and taken the square root, and that gives us a standard deviation of 13.36 approximately. But of course, we're probably going to use our graphics display calculator. Just like before, we enter the data into list 1. We want a frequency of 1. And then we go into calc, which is F2, and hit F1 for one variable. And here's the standard deviation here, 13.36. It doesn't show variance, so if you want variance, you're going to have to square that. There's a difference between these two. Okay, this is the population standard deviation, which is the one that we're going to use. SX is a sample standard deviation. You will find some textbooks do refer to this, but in an exam, we're only interested in the population standard deviation. Okay, to summarize, when we analyze a set of statistics, we are interested in the center of the data, mean, median, mode, how spread out the data is, range, interquartile range, standard deviation, the shape of the distribution, symmetrical, positive or negatively skewed, or bimodal. All right, our last lesson, for the topic of statistics is bivariate data.